All right, so welcome back. This is the halfway point of the course. And so in the second half of this course, we focus on data structures and algorithms. So we'll do lists and list-based data structures. Then we'll move on to algorithm and algorithm analysis. And then we'll go back to data structures and look at tree-based data structures, binary search trees and heaps both. So we're going to start with lists. And you're already familiar with lists, right? You've been using array lists ever since we introduced them, hopefully. And the motivation here is that they are way better than simple arrays because they dynamically grow or shrink, and they leverage the object-oriented programming principles that we've discussed. You don't have to worry about the details of how they grow and shrink or how they store stuff because of encapsulation and abstraction. We've also seen inheritance where you can have more than one type of a list or more than one type of a map or set. And then of course polymorphism where you can have a list that stores not just integers but just anything, right? So what we're going to do is we're going to make our own list. We'll start out with an array-based list just to understand how they work. And it'll be a great practice in iterative design and testing. Now, in practice, you would never actually write your own list unless you were required to do so, like part of this course and your last assignment is to do this. But instead, you would use the ones that are built into the language or built into a standard library. But the reason that we still cover this is so that you understand how they work internally, so that you know that, okay, well, if I used a linked list in this application, it's actually going to be really, really inefficient. If I used an array-based list in this application, it'll be efficient, but in that other application, they get swapped around. And in fact, that's going to be our quintessential example when we get to algorithm and algorithm analysis. So to start out with, let's review why arrays are bad, right? Arrays are bad because they have only one size. Once they're created, that size is fixed and it cannot be changed, right? That if I created an integer array here, it can only hold integers. It can only hold 10 of them, right? And if I only want to hold 5 of them, I'm wasting those 5 other spaces. If I want to hold 11 of them, I'm out of luck, right? In C, it's even worse because you have a lot of bookkeeping to do. Anytime you need to pass an array to a function, right, you have to tell it how big that array is, right? Because there's no way of telling. You may have to clean up after yourself in C, right? You don't have to do that in Java. Deleting or removing elements might leave gaps. So if I've got 10 elements and I remove this one right in the middle, right, I've either got a gap there or I have to do some extra bookkeeping and extra work to shift everything down, right? The solution to all this is, of course, defining your own data structure, your own dynamic list data structure, or since Java has already done that for you, right? The advantage here is that it automatically resizes, it grows or shrinks based on the elements as you add them and remove them, modify them, etc. We don't have to worry about those details because of abstraction and encapsulation, right? The abstraction here is that we just know that there are public functions that we use to add stuff and remove stuff. The encapsulation is that all those details are hidden away inside the class, right? So we're going to go ahead and start out with functionality. When worrying about functionality, you have to worry about the same 4 items as with databases that we just covered. CRUD, right? Create, retrieve, update, and destroy. Creating something means that you insert or add things to a list. Retrieving means that you get something that's already in the list, and that can mean many things. You could get the first element, the ith element, index-based. You could get the last element, the element that matches some criteria, right? I want the first appearance of 5 or something, right? You could do one or all of these things. In fact, we'll eventually do them all, but we're going to want to start somewhere. A update is simply a remove and replace. So if you want to update this element, then you can do that as far as a destroy that element, and then insert that element, a new element in its place. So we're not going to worry about update too much because that can be done in the other with respect to the others. But then destroy. How do you delete something in the list? Okay. So those are going to be our four basic, or three to start out with, three basic operations that we're going to want to design. As we do this, first with an array-based list, then eventually with a linked list, we're going to want to go back and forth on this. We're going to want to, first of all, design the interface. And by interface, I don't mean a Java interface, right? The interface of Java would be like like defining a collection of public methods. But I mean the concept of an interface, how you interact with the actual object. In other words, publicly facing methods. Then we're going to want to design tests. Right? This is sometimes this is called design test-driven development, where if strict adherence to TDD would say that you need to write all of your tests completely before you even write the first line of code in your class. I don't agree with that because this is an iterative process. The design is going to inform the tests. When we have the tests, we can implement the interface. But then we're going to come up with problems, right? You always come up with problems. Oh, well, it was not designed well. We need to go back and fix that thing, right? Or we need to go back and change that thing or change its functionality. Then we run the tests again to make sure that it didn't break. And then we realize we can make something more efficient, so we'll update the implementation again without doing changing the design, et cetera, right? We're going to go back and forth on these three things of design, implementation, and test. And we're going to go back and forth all the way through. It's not going to be some linear thing where you do A, then B, then C. It's not going to be some cycle where you're going A, B, C, and then go back to A, right? We're going to go A, B, C, B, A, C, C. We're going to go all over the place, right? Because that's how it's actually done in practice, all right? All right, so I've already set up a project here, or not project, but a package here. Let's go ahead and create a class. Now, my first design here is I'm going to be concerned only with integers, right? I want to get the basic functionality done first. So let's go ahead and create an array list for integers, okay? And we're not going to cheat. We're not going to use the built-in array list here somehow, right? We're going to say, no, we live in a world where that does not exist because we want to design and implement our own to see how it works, okay? Initially, it's only going to be for integers, and that's why I'm calling it my integer array list here. And it's going to be based on an array. In other words, inside the class, we're not public, but we're going to have an integer array, right? Int ARR. We were discussing how to do that yesterday. There are two ways of doing this, right? You can keep the brackets on the int. That is not C style at all, right? This is C style over here. And that's what I actually prefer to do personally, simply because that's how you use it in practice. When you actually go to put an index variable in there, right, you put them after, you don't put them first. Other adherents would say, no, you need it's a type, so it needs to be right there. The type needs to all be in the same place, right? You can go back and forth on that and argue, right? Anyway, so there's my array. The internal to this class, that's where I'm actually going to store stuff because at the end of the day, you're not going to get away from some memory chunk being located somewhere in the computer where the actual integers are being stored. So we do need an array at the end of the day, but we're going to surround it with this class that encapsulates and abstracts all the details away so that we can just use it outside this class, okay? To do, anything else? All right. So we'll come back to that, all right? Because we might need some other state here because again, we're going to go back and forth on design and implementation, right? All right, so let's go ahead and create some of these functions. Let's start with create. Give me a function that you'd like to have if you were using a list. Again, forget that you live in a world where lists are already made for you in Java. First of all, we're going to make it public because if it's private, it's not part of the interface. If it's private, nobody can use it except for the class, which may mean that we do want private methods, but if I'm designing the interface, I want it to be public, at least at first, okay? I want this to be able to put stuff into this list. So how about an add method, right? And we're going to add X to the list, Okay. Now, what should my return type be here? I'm the list. You gave me X, and I'm going to put this list X into the list. Do you expect anything back? No. Okay, so void. Right? And this is also why we like to write documentation first, because now we need to describe what it does, or our expectations for what it does. So this method adds the given element X to this list, ... Where would you add it? With no other qualifications here. So if the list was initially empty and I added 10, of course, it'd look like that at the end. But if 10 and 20 were already in there and I want to add 30, right, where would 30 end up going? In some random location right in between? Nah, that doesn't randomly add. Right? You could say that. You could write randomly add, right? And then it'll add it to a random location, right? But if you were to just add this, what would your expectation be? Where would you want to add it? The end. All right. Then we put that in our documentation to this list to the end of this list, right there, and get rid of our cruft there. Right. We're not even going to touch this. Instead, we're going to write some other tests first. Right. But before we do that, let's agree on the rest of the interface here. What about retrieve? Right. So let's go ahead and write another method here to retrieve something. What should the return type be, first of all? So if you have a list of integers and you want one of them, here you go. What did I just give back to you? An integer, right? What do you want to call this function? Retrieve? Right? Okay. Remember, there are only two difficult things, caching validation and naming things. In other words, what we did yesterday was get, right? But retrieve is fine. All right, retrieve what? Retrieve the first element, the ith element, the last element, the element that matches some criteria. What do you want to do? We're eventually going to do all of them. Ith? Okay. Why'd you immediately go to ith, by the way?
Because you can do it.
Once you've got this done, what can you do? What's about getting the first? Just call this other function. What about getting the last? Call this function, right? In other words, this is already the most general that you can do, at least as far as indexing goes, right? So, returns the element at the given code index. Okay, there we go. I am not going to implement this. Instead, I'm going to return a dummy value here. And what I should have been doing all along is a bunch of to-dos. Implement, right? Just to remind myself that I need to implement that. If you're really paranoid and think that you're still going to forget it, then you can always throw a new unsupported method exception or something like that. Not yet implemented. I don't know. There's probably something in there with a better name, but I'll just go ahead and go with runtime exception right now. Right? So that if ever you tried to actually use this, you know, oh yeah, I never implemented that yet. Right? We're going to do that there too. Okay. I can get rid of that. Yeah, there we go. Okay. So add retrieve. That's the CR of CRUD. We're going to worry about the update later on. What about the destroy? We need to delete something in the list. Are you going to delete the first element, the last element, the ith element, the element that matches some criteria? What do you want to do? All right, public delete or remove. Right? Let's say remove int index. So we're going to do index based here as well. Okay, and we've not yet implemented this. What's going to be my return type here? I could start out with a void, right? I could say, all right, delete that second element right there, the element at the ith index. Right? But what would be more flexible? What would be more usable instead of me just taking this and throwing it away? You told me to remove it, but if I just removed it and what if I gave it back to you? You're free to ignore it, right? We did this with respect to our database calls, right? Remember, we designed the insert method. Initially, it was a void, right? We'll go ahead and take care of that and put it into the database for you. But then we thought, well, wait a second, we could also communicate some extra information back. the primary key that was just generated by that insertion, right? And then we said, well, wait a second. We could take that to another level and say, well, not just the primary key, but the entire object itself with the primary key set. So always be thinking about how you can make it more flexible. In this case, I'll say int, because what we're going to do is we're going to say removes and returns the element at the given index. Right there. That's my expectation for this function. And again, this is why we write documentation, so that we know what we're doing. We have a good blueprint here, a description of what this function should be doing. Now, once again, I'm not even going to write a single line of code here. What I'm going to do is I'm going to first create a test suite for this using JUnit. So my integer array list tests. All right, there we go. All right, let's go ahead and create a test here. And they're always going to be public void, and then I'll call it test01 for initially here. We're going to come back and give that a better name. We're going to go ahead and add JUnit5 to the build path. Of course, you could do that. Remember, how do you do that? You go right-click your project, build path, add libraries, right there, JUnit, and then make sure that you select JUnit5 because that's been the de facto for quite a while now. And then we're good. And then, of course, you still need to import this. Import it from JUnit, okay? And now you're all set to test this. All right, well, to test your implementation, you would need a instance of your list. So let's go ahead and create a myInteger array list, just call it list, is equal to new myInteger array list, okay? And then let's go ahead and test the add method because that's the first one we designed. List.add 10. List.add 20 and 30. Right. Okay. Now what's our expectation here? What should the list look like after we've added each one of these successively? 10, 20, and then 30 because we're always adding to the end. Right? How can we test that expectation? Right? Well, what we could do is we could go to this list here and make this public for the purposes of testing. And then what we could say is let's create an array here. So int expected is equal to 10, 20, and 30. All right, there's my there's the array that I would expect it to be, and then we can say list dot array, and if they're equal, right, assert equals the expected and the list array should be the same thing there. Right? Now, I need to import this as well. I've got to be careful because it should be from assertions. There we go. All right. So there's one test, but I'm breaking encapsulation, right? I'm making this public just for the purposes of testing, right? And then once I'm done testing, I come back and I fix it so I'm no longer breaking encapsulation. Well, now it's broken over here. So is that a good, that's no better than ad hoc testing, right? Where you're writing a main and then printing it out or something like that. I don't like that. So let's think of another way, private, where we don't have to break encapsulation here. And by the way, there is another way of doing this. You'd have to use metaprogramming. You'd have to use you'd actually break it open using aspect-oriented programming, which is something we're not going to touch at all, right? But there's my expectation, right? So sometimes you can't just test one method. Right? Instead, you're going to have to test two of them in tandem together because they go hand in hand. So in this case, if I were to test the get method at the same time, or what would we call it, retrieve? All right, there we go, retrieve, 0. What would you expect that to be? So int expected is going to be 10 for the first one, right? And then int actual is going to be our result after retrieving the 0th element. Then we'll assert equals that the expected is equal to the actual. Right? We can then repeat that. In fact, I'm going to repeat it I'm going to write less code here, int expected and actual, right, so that I don't re-declare those. And then that allows me to copy, paste, right? 20, 20, and then 1 and 2. Actually should be 30, right? So all I'm doing is I'm testing 3 different calls to add, 3 different calls to retrieve, okay? All right, we do not yet have a test for remove, but like I said, we're gonna go back and forth on this because I don't wanna just write all of my tests and realize I did something wrong with the design and then have to go back and rewrite my tests. Everything is gonna be iterative. So let's come back over here and actually implement one of these things now, right? What about add? Right? So I wanna add it to the end of the list. So this dot array, I'm going to put it somewhere, is equal to x. I'm going to put it somewhere in the array that's inside the class. Where do I put it? That's always at the beginning, right? That would always be the second element. That would be the third element. Right? So if there are already 3 elements in there, 10, 20, and 30, where would you want to place it? At what index would you want to place it? At 3, right? Because there are 3 elements in there already. What if there were 4 elements in there already? Where would you want to place it? Index 4. So that tells me that we need to maybe keep track of how many elements are in there. So private int size. Now this size is not the size of the array. You can think of the size of the array as a capacity. You're able to hold 10 elements or 100 elements or something like that, but there are only 5 elements in there at that moment, okay? I'm going to leave that there because I don't know if I'm done designing that. So if I have that size, this dot size is where I want to put it. Okay? All right. So let's come over here and let's run it and see if it works now. Right. Null pointer exception. Cannot store int to array because this dot arr is null. Excellent. What did we forget to do over here? Do we ever set ARR? Do we ever set size? What do we need? Something to initialize this object. We call those constructors, right? There we go. So the default constructor here, this dot size, I haven't put anything into it yet. So what size should it be? 0. So this dot array, what should I initialize that to? New int array of size 0? It's not that helpful, right? Remember that this 0 and this 0 are not the same thing. The size tells you how many things are stored in there. This tells you its capacity. And if it's an initial capacity of 0, we're not getting away with anything. Right? So let me go ahead and put in 10 there as an initial capacity. You can hold up to 10 elements in this list, okay? Does that solve our problem over here? Well, it solves that null pointer exception, right? But then we've got that runtime exception not yet implemented in the retrieve over here, okay? So let's come back over here and continue. Again, we're going back and forth on this. Right? So I want to retrieve the element at that index, okay? Return what? This dot array of index. That's what you asked for. That's it. Let's come back over here and see if we get what we want. All right, so what's the problem? Well, the expected value for the first value was 10, but we actually got 30. Why was that? At this point, you can fire up your debugger, right? Nothing part of this. Like your well, I should have put it as part of this. That you design the interface, you design your test, you implement your interface, then you run your test. But then what happens? Debugging, right? Debug as necessary, right? Okay, I should have put that in there, right? I can't believe I didn't, right? Because probably yesterday I didn't make as many mistakes, right? So let's go ahead and set a breakpoint right where on line 21. So okay, on like retrieve. I can set a breakpoint here, I think. Yeah, and let's go ahead and debug. Will it actually switch yet? Yes, it'll debug while you're running a test, while you're running a JUnit test. All right, so now we can take a look around here. Let's look at the variables here. We've got this list here. And if I expand that out, I can start looking at the guts of the list, the internals of the list. We've got an array here, which has a capacity of 10. 30 is the first element, but I inserted 10 and 20, right? there's your other hint. The size is still 0? Did we ever actually update the size when we added stuff? Nope. So let's go back over here to the JUnit, or the Java perspective. And when you add something, right, what else do you need to do? Say that we've added something, right? And now the size is there. I think that this might work now, and it does. Does that mean it's perfect? We only tested this for 3 elements. Right? Let's really give it a test. First of all, I'm going to rename this, right? Test, get, add, and get, right? And those will be, yeah, continue. I should have stopped over here. My debugger was still running over there. All right, but it's stopped now. All right, good. All right, so this is going to be test and get. I'm going to rewrite this so that I'm not just doing 3 elements. Terminate it, sorry, there we go. All right. A whole bunch of elements, bulk, okay? We're gonna give this a full workout. For int I equals 10, I is less than or equal to 1,000, I plus equals 10. I'm gonna go by 10, 20, 30, 40. I'm gonna go all the way up to 1,000. How many elements is that if I'm going up by tens? 100, right? So list.add I. Right? Now, how do I actually get add the expectation after that? Right? Basically, what I was doing is I'm doing it now 100 times instead of just 3 times. The expectation here is that it should be 10, 20, 30, ... to 1,000. Right? Okay. How do I test that for all 1,000s? Another for loop. For int I equals 0, I is less than 100. Remember that there are 100 elements in there. I plus plus. I will get the ith element. Right? So the actual will be not 0, but I. Right? And we can go ahead and, let's go ahead and reuse this up here. There we go. And how do I get the expected? Well, I designed this test to go up by tens, right? So the first element should be 10, the second element should be 20, right? In terms of I, that is I plus 1 times 10, right? So when you design your tests like this, design them with math in mind, right? That it makes it very, very predictable on what it should be, right? There's my actual, there's my expected, okay? And I can get rid of all of that there, okay? All right, let's run it and see if it works now. And immediately it dies. Index 10 out of bounds for length 10. What happens when we try to insert 10 elements in there? Everything's perfectly fine because we had a capacity of 10. The 11th element, that's when we're out of bounds because that's going to be index 10. So back to the drawing board here. This is why I'm not erasing these to-dos until we're absolutely done, right? What needs to happen here first? I need to know if is the capacity big enough to handle it, right? So if the array is full, then what should I do? Increase its capacity somehow, okay? How do I determine if the array is full? All right, well, we kind of have that, right? The array.length, right? Right? That's an upgrade from C, right? Because now we don't have to do the bookkeeping ourselves. It's done by Java for us. If that's equal to the size, then we know that we've hit our capacity. In fact, size, that seems like it might be useful. Remember when we did this over here? I hard-coded this to 100. I don't like hard-coding stuff, not even in tests. It would have been better if we said list.size here, because that's an idiomatic for loop, right? Except we don't have that thing. That's all right. Back to the design part, right? So come down over here, and let's go ahead and add a public int size method. Return this.size. And documentation returns the current size of this list. Don't have to get crazy with your documentation, okay? That means that we can change this to this.size. It's not that big of a deal. That's not that big of a change. But I don't like this because it doesn't roll off the tongue when you're reading this. This dot arrays dot length, oh yeah, that means capacity, right? Is equal to this dot size. Okay. What if I had is full? Doesn't that roll off the tongue way better? Isn't that much more readable, right? So let's go ahead and add that as well, but I don't want to make that public. All right, let's make it public initially. It's going to be a Boolean, is full, right? And all it's going to do is return that, return this, and then we don't have to do another function call here. I'll just go size, right? Best to put that into parentheses though, just to understand that it is an expression. Right? Some folks would actually write an if-else-if statement. If this is true, then return true. If this is false, return false. Don't write that, right? Don't write an if-else condition if you can go ahead and just get away with the expression here itself. Why don't you like this being public though? Why don't I predict why I don't like this to be public? It's not useful, and it's a leaky abstraction. You remember what we called those things? You don't need this. In fact, when you're using this list, it's dynamic. It should grow automatically. Why would I ever need to check that it's full? I should never have the concept of fullness. If it's truly full, that means that you've run out of memory and it's time to buy more RAM. Right? And there's really nothing that I can do in software to fix that. Right? So let's come back up here, and that rolls off the tongue, but we are making it private so that nobody can access it. It's no longer a leaky abstraction. Right? I'll put that in the notes too. Private to make it not a leaky abstraction. Right? But otherwise returns true if the internal array has reached its capacity. Right? And then it's time to increase its capacity. How do we do that? We need a new array. New ARR is equal to new int of what size? The old array, whatever its length was, plus 10 more, right? If it was 1,000 before, now it's going to be 1,010, right? There are some other ways that you could do this, and this needs to be an integer array. There we go. There are some other ways that you could do this. For example, you could double the size of the array. Problem there is that when you're getting to larger arrays, right? Say that you only need 1 megabyte and then a few bytes after that. You end up allocating 2 megabytes, right? So we're going to keep it small. And in fact, what you would do in practice is you would have a whole test suite where you're testing empiricalness, right? How much wasted memory is there under random conditions? How much slower does it get? How much faster does it get? You're going to try to find that sweet spot where it works on most things. Right? So we've created a brand new array. We now need to copy everything over. So that's going to be a for loop for int I equals 0. I is less than this dot array dot length. I plus plus. The new array I will receive the old array of I. And then at the end, ARR, we're going to say that this dot ARR is equal to the new ARR. Right? We're replacing our internal array here. Now in a programming language like C or C++, what else would you have to do? You'd have to free the old array. Right? Do we have to do that in Java? Nope. We let the garbage handler take care of that for us. Okay? Let's see if this works. Hey, it did. Right? Now we're able to insert over 100 elements and know that they're all correct. Okay? Except that this seems like a lot of code, even though it's only 4 lines. Right? It seems like it's such a fundamental operation of cloning basically a new array with a larger capacity that there should already be something built in there for you. And in fact, there is. This dot array is equal to arrays dot copy of the old array. And what we're going to do is the old array, this dot array dot length plus 10. If you read the documentation on this, it'll tell you that it copies over everything, and then with the extra capacity, it pads it out with zeros. Right? If you went with minus 10, it would still work because it would copy everything except for the last 10 elements, right? So we're going to go ahead and go with plus 10 here because, of course, we're not trying to get rid of anything. Now, which one is better? Which one is better from a coding perspective? My 4 lines of code or this one-liner that reuses something in the library? This one, right? Not only that, but from a performance perspective, this is way better. Because if you take a look at this, right, copy of, all they're doing is calling this, this array copy, which is in the system. Right? Now that array copy is what's called a native method. Right? In fact, it's what's called an intrinsic candidate here. Right? What that means, well, here, let's start with native. What that means is probably under the hood is a bunch of C, right? In fact, it's a C malloc and a C memcpy. Did you ever do those? Memcpy? So you did malloc, of course, right? That's going to allocate stuff. You did malloc? Okay. And then memcpy, that's going to copy one chunk of memory to another chunk of memory, right? And so it's really two lines of code there in C. And then this intrinsic candidate is even better because it says that if your processor supports accelerated hardware stuff, like specialty stuff, then go ahead and use that as well, right? So those are intrinsic, calls on the hardware, on the processor itself. So it's going to be blazing. This is blazingly fast. Right? Our little for loop, no, our little for loop is terrible compared to this as far as performance goes. Okay, so this is much better right here. Okay, I'm somewhat satisfied with that implementation, so I'll go ahead and get rid of that unless I need to come back someday. Right? Okay, especially because all the tests still pass. Why did I run it again? It worked before. I made changes. Right? Even though those were better changes, I still refactored it. I still updated it. I need to run my tests. And this is why test suites like this are much better than ad hoc testing. Because if I had made a change, I would have to manually run all my ad hoc testing again. This one is just a single button press, and we're done. Green means good. Okay? All right, well, that's get and test, 3 elements, and get and test bulk, right? What am I not really testing for here, though? Let me go ahead and create another test here. Test, public void, test 01. I'll come back and rename it right, once we've revealed what we're testing. Let's go ahead and create a list here, my integer array list. There we go. And list dot get the element at the 0th index, int actual. So what is my expectation here? Int expectation, or expected is better because it's shorter. Not get, but retrieve. I don't like retrieve because now I have to remember I before E except after C, but I've been doing well enough so far, so I guess we're okay. Right? What would you expect here? Have we put anything into the list yet? Nope. So how can you get the first element if it doesn't exist? I'm expecting 10. That's nonsense, but it's also going to fail. Right? There we go. Hopefully it fails. There we go. All right. All right. The expectation, that was nonsense anyway, but I actually got 0 out of this. Why? Yeah, Java automatically fills it in with zeros. So if you're asking for the 0th element here, well, of course it's going to be initialized to 0, and that's why you get it. Should that happen? No. So what should we check for here instead of just giving it to you? Here's another test. What if I said, oh, well, give me the negative 10th element? Does that sound right? No. Give me the 5,000th element, right, when we haven't inserted anything. Right? So what should we be checking for over here? If index is less than 0, or if the index is greater than size, this dot size, if it exceeds this size, right, then we'll do something else. Now let's think about that because we might be off by 1 there. If there are 5 elements in there, what are valid? 0, 1, 2, 3, 4, right? So greater than equal to. Don't ask for the fifth, index 5 if there are only 5 elements in there because of zero indexing, so careful. What do you want to do here? Return -1? What if you had happened to put -1 in there? How do you distinguish between -1 was in there versus, oh, that's an error condition? Besides, in Java, how do we handle errors? We throw things, throw a tantrum here. Throw a new runtime exception, right? And a message. Index equals plus index plus is not valid for a list of size plus size. Right? Okay. Note here that we did. I mean, we got a weird result. But even if we had asked for something completely different, like 5,000, right? Then we would have gotten an array index out of bounds exception. An array? I don't see any array here, right? Leaky abstraction. It would have exposed information about how we are storing stuff inside this class to the outside world. By me writing my own exception here, runtime exception, with my own message, right, then we're not exposing that, okay? Now, how do we test for that? Right? I don't have an expected anymore, right? Instead, it's going to throw an index 5,000 is not valid for a list of size 0. I'm getting, that passes, right? But this fails, right? So when you're trying to test error conditions, what you do is you assert throws instead, right? And it's going to throw a runtime exception dot class. That's the type of exception it throws. And then you need, the modern way of doing this is this is called a lambda. Don't worry about it. Assert throws from assertions. There we go. All right. This is the way that it works, right? You want to assert that this list.retrieve code is going to end up throwing a runtime exception here. Have you seen lambdas in Python? Not in Python. Have you seen lambdas in Java before? It's nothing special. It's an anonymous function, right? So you have these kind of. Now, I wouldn't call them lambdas, but you have them kind of in C. Did you ever do function pointers in C? No? All right, so I forget the syntax off the top of my head too, but basically this is all right, well, I don't care, I'm not going to give this a name, right? Like if I gave this a name like foo, now the function has a name. It's not correct syntax, but the name of the function is foo, right? It's a nameless function, and it maps to this function call right here, all right? Let's run it again, and that should all be green now, because it indeed does throw that runtime exception, right, when I call this code right here. So let's rename this now. Test index bounds test 0.1. And I'm gonna call it 0.1 because I'm gonna want to test a couple of other things here. 0.2 and 0.3. I should test negative values. I should test a valid index, otherwise valid index, but that's not going to be valid because I haven't put anything into the list yet. In fact, if you want to go a step further here, ask for 4, but list.add 10, 20, and 30. 20, 30, there we go. So should I be able to ask for the 5th element at index 4 there? No. Right. And note there that I've got now 5 tests for the price of 1, or I got 3 tests out of that for the price of 1. Just by varying my my function calls there, right? More tests is generally better. I'm testing something negative. I'm testing something ridiculously large. I'm testing something reasonable, but in the context, it's an error. Okay. All right. Do I need to do the same thing here, by the way? Do I need to test for indexing on the add method? There are no indexes, right? You're just adding it to the end. Right, no matter what. With all that knowledge in mind, let's go ahead and do the remove now. Right? So what's the very first thing I should do since I'm giving you an index? I should remember we're removing and returning the element at the given index, so error checking. Right? So if you give me an invalid index one way or an invalid index the other way, I'm going to throw that exception at you. Otherwise, just simply, let's save it off. Save off the element for its return value. So int result is equal to this dot array of index. I know that this is valid here because I've already checked for indexing over here. Right? And then at the end, I'm going to return result. Right? Now that doesn't actually remove it, does it? Okay. So let's whiteboard this. And by whiteboarding, if my streaming supported whiteboarding, it does. I didn't set up my iPad though. But if we were actually whiteboarding this, I would write down an example: 10, 20, 30, 40, and 50. And then we want to remove, say, 20. All right. What should it look like after that? Should it look like 10, XX, 30, 40, 50? Do we want a gap in there? Nope. Should it look like 0? Reset it to 0? No, because how do you determine whether or not you put 0 in there at some point or not? -1 would just be just as bad, because you can put negatives in there. Right? Null is not even a possibility because they're primitive types, ints instead of integers. Right? I want it to look like that. I don't want any gaps in there. Right? So how are we going to remove that? This is where whiteboarding comes in. I take the 30 and what do I do with it? I move it over there. I take the 40 and what do I do with it? I move it over there. I take the 50 and I move it over there. Do I need to do anything with the 50? No, just leave it alone. Right? Leave it alone. There's a 50 over here, but because I am decreasing the size, it gets ignored. Right? Now we just need to translate that idea into actual code. A for loop, starting where? At index. Right? While I is less than or equal to something, I don't know, we'll come back to that. I++. And I'm going to move the I+1th element down to the ith element. So this dot array sub I is equal to this dot array sub I+1. Okay. Now I left this blank here because do we need to go all the way to this last 50? No. We just need to go up to this dot size -1 and -2 technically because we're off by 1, right? Because of 0 indexing. This would go all the way to that end 50 element. This one stops short of it. Okay. What else do we need to do? If it had 5 elements before, now it has 4. So this dot size minus. Right? Get rid of the cruft. There. Perfect. Right? Let's write some tests for it. At test. Public void test add and delete bulk. I'm immediately going to jump up to a bulk here, right? And I'm going to steal some code from up here because we're going to create a list and add 100 things to it. Okay? Now, which things do you want to delete? For int I equals 0, I is less than 100 for now, I++. We can say list.remove, right? Remove what? At the beginning? The second element always? The last element always, which would be list.size -1? I'd say that you need to test all of those at some point. Let's go ahead and test just from the front, right? Test and delete bulk from front. Right? And then add some documentation on what you mean by that, right? And we're going to say int actual is equal to this. And here int expected is going to be the math from before. If there's 10, 20, 30, 40, 50 in there, then I should expect that it's I plus 1 times 10. And that I would actually, now let's go ahead and steal the assert equals code up there. There we go. Right? Because I'm taking out 10, then I'm taking out 20, then I'm taking out 30, right? Everything gets shifted down on each iteration of this, right? And then at the very end, how big should it be? Size should be 0, right? List.size. Let's just check. Right? We're actually never really testing this up above. We should have been, but we'll go ahead and test this as well. Right? All right. Green. Right? We did it right the first time, right? Okay. Now, what else did we not do in here that our tests are not showing? We expanded it up here if we needed it to. Right? Down here, are we shrinking it if we need to? No, but we could put that in as a to-do, right? Consider shrinking the array if the capacity, unused capacity is too large. And I'll put that into quotes because what do you mean by too large, right? It's probably not worth it to clean up 1,000 megabytes, or 1,000 megabytes, yes, but it's probably not worth it to clean up like 1 kilobyte or even 50 kilobytes, right? So we might have a different standard here than we had up here of just add 10 more bytes, add 10 more bytes, right? So I'll put that in as a to-do. And by the way, what would it look like? It would just say that if the array minus the array minus the size, that gives you the unused capacity, is greater than your threshold of tolerance or whatever, it would be a call to this where it's now minus something, XX, right? So it's going to be very, very similar code, and that's why I'm not going to do it. I'll leave it up to you if you want to do it, okay? All right, cool. We have got basic CRUD out of this, right? We've got a create, retrieve, update, and destroy, and it's well designed, no leaky abstractions, any of that stuff. So let's think about secondary functionality now, right? So for example, bulk operations, right? Add all. If I gave you an entire other list, you would want to add them all. Clear all, that is, we're not going to just delete the first element or the fifth element or the 12th element, we're going to delete them all, right? You could also have, say, get a new copy, right? A deep copy function, a new deep copy function that is a sublist, right? You could merge two lists together, right? You could have a copy constructor. Takes another list and creates a deep copy of the list, right? You could have other convenience functions. One that I always think of having is, say, contains, right? Does it contain 40, right? And if so, maybe I want to know where it is. So that would be another function, index of, right? So give me the first index at which you find 40, right? Do we have any others? Right. All right, so that's a good list to start out with. Just to get some more practice here, what would you want? Oh, and then we never did update either, right? Update, right? That is replace a given element with another, right? Something like that. So what do you want to do? We've got 20 minutes. We can do 2 or 3 of them. Right? Update, okay. I'm going to call it replace though, because that's actually what it's going to do, right? So public void replace int x int index. Why am I taking both of those things? I want you to replace the element at that particular index with this element right here, right? So replaces the element at index at code index with the given element x. Okay? All right, what's the first thing we should do since we're dealing with indices?
Oh, tests.
Yeah, test the indexes. So is the index correct, right? Throw that, if not. All right, otherwise, we're good. So I can say this dot arr sub index is equal to x. I just replaced it. That's it.
Since we're using that tester so many times, would it be good to have our own like method or function for that? Call?
What do you mean?
So like because we're just kind of repeating the same thing over and over, could we do like maybe like it?
Oh, like this chunk here, right here.
Yeah.
Right, yes. Good observation. We could put that into, would we want that to be in a public method though?
Private.
Private,
Yeah.
because we don't like leaky abstractions. Private, Boolean, check, check, actually we don't need it to be Boolean either if we're going to throw in an exception, check bounds, right? And that'll be int index. Right? There we go. I like that. Right? And then we'll return true if we get past that point. Right? You don't actually need to do that. You can make this a void function because if you end up throwing the exception, then then normal control flow gets truncated there. So yeah, we could do that. Check bounds. Oops. Check bounds of index. I like that a lot. Why? Because we're no longer violating the DRY principle, the don't repeat yourself principle. Right? All right, and I'll leave that to do in there. Not only that, but we're trading 3 lines of code 3 times each for 1 function. Right? Much, much better. Good. Right? Back to replace though. Right? So we check the bounds, we replace it. Okay, that'll work, and I won't even bother writing tests for this because it is simple enough, but to do for you, write tests for it, right? To do, write tests for this, right? Should we redesign this though? Again, we're going to go back and forth here. We're going to go back and forth between designing, implementing, testing, etc. Can we make anytime I see a void function, I think, can I make it more expressive? Can I make it more usable? Right? What if I were to return what you just replaced? Right? Replaces and returns the element at that given index. Right? To do write test for it. So I need to save it off first of all. Int result is equal to this dot ARR sub index, right? And then I can return the result. Right? So we make it a little bit more flexible. You can always ignore it. I don't care about it. Just replace it with that index, with that element. Okay. All right. Any others? Contains. All right. In fact, I'm going to do both of these at the same time here. So eventually you might take like a theory course or something. These are there's something called reductions, where you can say that one problem is no harder than another if you can reduce one to the other, right? And technically what that means is 2 functions. Can one function be written in terms of the other function? So think about these 2 functions. Which one would you write first that is more general? Contains would return a Boolean, true or false, right? Index of would return, if there are 5 things, 0, 1, 2, 3, or 4, right? Or what do we do with an unsuccessful search? -1. So if you got a -1 out of this then it would be false up here. If you got anything other than a -1 up here, this would be true up here. So let's write the index of first. Public int index of, right? And an int a value, right? Okay. And here it's just for int I equals 0, I is less than this dot size, I plus plus. Idiomatic for loop here. If array, this dot array of I is equal to that value, then we'll go ahead and return I. Otherwise, we get down here and we never find what we're looking for. We'll go ahead and return -1. Document that. Right? Returns the index, the first index at which the given value is stored. Maybe there's a better way of phrasing that, but whatever. Right? Returns -1 in the case of no such element. Right? In the case that the value is not in there, the value is not in this list. Right? Now, what does public Boolean contains look like? Int value. I'm just simply going to call that other function. This dot index of value, right? And if that's equal to -1, then it's false. So if it's not equal to -1, then it's true. Right? And just return that expression. That's it. Always be writing as little code as you can. Reuse code, index of. Right? Wonderful. and then to do documentation. To do. Right. Okay. 10 minutes left, and we've done several of these.
Can we also make one with that for the number of occurrences?
For the what?
Number of occurrences
Oh, okay. So count, like public int value count. I don't know what a better name for that would be, but int value, right? Okay. So I'm going to steal some code up here. We might want to refactor it and reduce the amount of code later on, but oops, there we go. So if that is we don't return, instead we say count plus plus, and so we'll need that value there, int count, initialize it to 0, and then we return count. Right. Okay. Now we could rewrite this one in terms of this one, right? I don't see that we could rewrite this one in terms of this one over here, because just saying that there are 5 elements, there are 5 instances of 40 in there doesn't tell you where they are, right? So I think that this repeated code is necessary. Right? And then of course to do, document, right? Come back later. It actually should have been done first, but what about some of the other stuff that I mentioned before? Create. You know what? We have a create that always adds to the end, right? It always adds to the end. But our other methods, retrieve, is index-based. Our other method, remove, is also index-based. I'd really like an index-based add then, right? Just to be consistent. Public, void, add, int x, int index. Ooh, object-oriented programming quiz. I have 2 add methods there. They're both named the same thing. Why can I do that? Because they have different numbers of parameters, right? That is called function or method overloading, exactly. So, bringing to bear all those object-oriented programming principles. I'm not going to name it something else, add at index, right? Because it does the same thing as the other one, right? You know that if I gave you an index, I'm implying that I want you to add it at that index. So let's steal that documentation actually. Right. Adds the given element x to the list at the given index. This is probably the last thing we'll be able to do today, because this is going to be a little bit more substantial. All right. First thing I should do is what? Check bounds, but be careful here. Let's whiteboard some of this. 10, 20, 30. Right? And I want to insert 42 at index 0. What would that look like at index 0? Then you're inserting it at the beginning, right? 42, 10, 20, 30. What if you were to do it at index 1? You know what? Can I create a new file here? I'm always doing this inside the code and then erasing it. What if I created some file, I always call it dev.markdown because it's a markdown file, and then dev because I'm developing. That's my whiteboard right here, right? Okay, I don't want to preview. All right, that's terrible. All right, I should have done, don't save. It's not a great markdown editor. So let's just go with file dev.txt. There. All right. If I were to insert it at index 1, what would it look like? 10, 42, 20, and 30. Dot, dot, dot. What about index, say, 4? Is that valid? Remember, it's 10, 20, 30 before, and 42 right at the end. I think that's valid. Oh, sorry, 4. There's 0, 1, 2, 3. I was wrong, 3. Right? If I had just done 2 there, I would have realized it. 2, it should end up being 40, and then 42, and then 30. So that seems like index 3 is actually valid to me. Right? I'm not going to be able to cut and paste my check bounds here. Instead, I'm going to copy and paste it and go back up here. And there we are. And I'm going to change it because size is okay. If there are 3 elements in there already, then you should be able to insert it at the end, right? That's index 3, okay? Otherwise, we'll throw you an exception here, okay? All right, back to the drawing board up here. How am I going to accomplish this? Oh yeah, sure, go ahead.
So why are we not able to just add or update the size before and then check it? Or, because we already have the function for checking it.
You could. Yeah, you could do that. But then if you ever debugging, you're gonna say, oh, why is the size 5 before I've actually inserted the 5th element there? So maybe there's an argument against it because of debugging, and it's like an indeterminate state. But yeah, that would work. Logically, that would work. This dot size plus plus, and then this dot check bounds for the index. That would work too, right? And you would, although it would only save you 1 line of code in the end. I don't know. Yes, that would work though. Right? Let's worry about this though. Right? How do I get 42 in there if it's 10, 20, 30 already? I need to make room for it, right? So I need to shift stuff down, okay? Before I shift stuff down, what do I need to make sure of? That there's room to shift stuff down, right? So here we're going to check the capacity as well. If this dot size is +1, if we were to add 1, and maybe here's another argument for why you would want to go with your direction, because you could actually simplify this code as well. If I were to add 1 more, would that match this capacity, this dot array dot length, right? Okay. And if that's the case, then I need to increase capacity. And for that, I'm going to steal this code. There we go. And now that it's in 2 places, I probably have an argument for don't repeat yourself and put it into another method, right? Where's my check bounds? Let's go also have a private void increase capacity. There, right? And then, yeah, that's all I wanted, right? And we'll use it up here, right here. Not bound, not remove, not, there we go. There. All right. Increase capacity, and then I can replace this 1-liner up here as well. The argument to do it that way would be that, well, what if I ever wanted to change it from 10 to 100? Or I wanted to change the strategy entirely, right? Well, now I've encapsulated it inside of a function, and I only have to change that one function for everything to work just as well. Okay? Pretty good so far. All right, so now I have room to shove stuff down to make room for x, dot, dot, dot. Right? So for int I, starting at index, I is less than something, I plus plus, I will say this dot array of I plus 1 is equal to this dot array of I. It's just the reverse as before, deleting it. I was shifting things down, now I'm shifting things up. Right? The one to the right is going to take this value right here. So I plus 1, I take I, and then put it into I plus 1. Okay? At the end, I need to make sure that I putting in that x. So this dot array of index is equal to x. Right? And then also I need to say that this dot size plus plus. Of course, you could go and simplify that by doing that first. And maybe this code gets simplified as well. Right? I don't know. I'd have to consider that. But that's also why we encourage partners, because then you can have a healthy debate back and forth on which one it should be. All right, so shove stuff down. Where do I stop? This dot size? Well, remember that I'm going +1 right here. Right? So if I'm right at the end, I probably want to go -1 again to not fall off the edge. Anytime you're using an index here and then you've got +1, that's probably screaming out, stop short 1, right? Because you're going to fall off the edge, right? Okay. All right, so I think that looks good. But let's go ahead and test it. I don't need to, one way of testing it without writing any more tests is which one of these functions should be calling the other function? Which one is more general? Adding it at an arbitrary index or always adding it at the last index? Arbitrary is more general, so why don't we say this dot add x at this dot size, right? Now implicitly when I test this function, I'm also testing this function down here because one function calls the other. Let's see if I broke anything. I didn't break anything. Awesome, right? But of course you would want to test this. With only 5 minutes left, I think we could do a really quick test. There. All right. Test add at index. All right, so we need I'm going to grab most of this code here. There. And very, very simply here, instead of adding it at an arbitrary index, I'm always going to add it at the front, right? Right? I'm going to end up adding it always at the beginning. Now, what's your expectation here? If I add 10 at the front, then 20, then 30, then 40, so what should you expect out of this list? Expected. What's the first element going to be at the very end? After doing all this? 1,000, then 990, then 980, dot, 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 then 30, 20, 10. That's my expectation. Let's go ahead and steal this code. And for all 100 of those elements, I'm going to expect, not remove, but get. There we go. Retrieve. There we go. Retrieve. Now I need to figure out the math. So, what would help me here? I don't like figuring out that kind of math. So what I'm going to do is I'm going to create another variable. Int value is equal to 1,000. All right. Expected is equal to the value. And at the end of the loop, we will say value minus 10. There's the, I don't want to think of the math off the top of my head kind of approach there. Right? Does it work? Oh, darn it, no. Expected 990, but it was 1,000. All right, expected, you retrieved. I went up to 1,000, right? All right, fine, debug. Switch to that perspective. All right, there's the list. There's the array. Oh, wait. Oh, I broke something up in the other one. Or did I? No. Oh, I never got rid of that. Okay, sorry. There we go. There we go. All right, I see. Oh, whoa. That's definitely wrong, right?
I think back in the add function, we're using, we're updating it, we're starting from the start, pushing everything forward, but that's copying the same thing across over.
Bingo. Good eye there. That's actually something I usually do on purpose, but I forgot that I did it on purpose. So the issue is that you're always caught, like, it was not like I was doing it over here. What happened was, say that we got 10, 20, and 30, right? And we want to insert it at the beginning, right? So what ends up happening is I end up copying 10 over to 20. Well, then what do I can't copy over 20 over to 30, so that gets copied over there. In this case, it was 990 all the way. Let's go ahead and stop, go back to our Java perspective, and fix this bug, right? So I don't want to start at the beginning and then copy things over because I'd be overwriting stuff. Instead, I will start at the end So that side, yeah, that's fine to start there. I is greater than or equal to this index, and then I minus minus. I will work from the end and then shift things over so that I plus 1 is equal to I, or sorry, this would be equals. All right, does that work? So I'm going to start at, well, you don't have to play any guesswork here. Let's go ahead and stop this. And let's just go ahead and run the test, see what they say. Oh, I didn't save it? Okay, save it. All right, still fails. That's because, let's see. We start at the end, right? So that's the last element that's being stored. And then we take I plus 1 is equal to I, and we I minus minus, and we go all the way to index. Do we go all the way to index? Yes, because the index needs to be moved over to index plus 1 to make room for index. All right? Maybe it didn't actually save. Run it again. Nope. All right, so where is that failing? On that line? No, on that line. All right, fine. So same break there. Let's go ahead and run it. Switch over. Looks like it worked to me. 990, 998, dot, 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 dot. Okay, so my math must be off here. Value, let's go ahead and walk one more. All right, so the value is 1,000. The retrieval value expected is 1,000. The retrieval value is 1,000. It works. Right? And then on the next iteration, we update the expected to 990. Retrieve is 1,000. So there. Oh, duh. Why am I always retrieving the first one? Right. What should that be? I. There we go. So in this case, my tests were wrong, right? And you'll always have that rare instance in which your test is wrong and your code is wrong, but they're wrong in the exact same way, and that's why they agree, right? But that's rare. Those are false positives, right? And there, 100% now. I don't know why you decided to go up there, but you should be down here. There we go. All right, 7 out of 7 tests, we're good. I will leave the rest of them for you to do on your own. Right? Some of these would be very, very useful, like a deep copy of a sublist, right? Merging two lists together, a copy constructor, et cetera, et cetera, et cetera. But at the end of the day, right, you're not going to use this list. Instead, you're going to use your own, or you're going to use what's built into the library. What we're going to do on Thursday is we're going to re-examine this. What is this list good for? Just integers, right? What do I want it to be good for? I want it to be for integers and doubles and strings and invoices and whatever else you want, right? In other words, we're going to look at the other two parts of object-oriented programming, in particular, polymorphism. How do we parameterize this class to not rely on integers? And then how does everything change as a result? Okay? So that's where we'll pick it up on Thursday. Otherwise, you've got lab 10? No, is it 10 this week? 9. 6, 7, 8, 9. And lab 9 is on JDBC, and you'll be doing that in the context of a web app. Whether or not you get the web app to work, hopefully it works locally for you. If it doesn't, then you can still at least run the JUnit tests. But otherwise, JDBC this week and next week. This Friday, your design document for your databases is due. Okay. And I'll see you upstairs if you're coming.